In our last video we went over the linear equation and I mentioned something in here called the gradient. Now the gradient is what actually defines the slope of our line here. Now to find the gradient we have a special rule to follow, and that rule is rise over run. Or you also look at it as rise as in the y-axis value over the x-axis value, which is the run. So rise and run. So you notice here in this equation, I'm going to write this down here, y equals 2x plus 2. Well, our gradient is here, but it isn't represented as a fraction. But we know that our gradient, for example, is, well, it's the rise over the run. So what does that look like in here? Well, we know that this is our gradient, so all we need to do is we know that 2 is a whole number and anything divided by 1 is itself. So our gradient represented in rise over run would actually be just 2 over 1. And that is our gradient. So what does this look like on a graph? Well, let's have a look. So we can see that this is our line represented by y equals 2x plus 2. Now I'm going to change this using my rise over run to 2 over 1. Now if we have a look at this line here, we can see that, alright, we have our y-intercept represented here. It goes through plus 2, where it goes through here. Now our gradient is 2x, or no, sorry, our gradient is 2, not 2x. We don't know what x is, it can be anything. Our gradient is 2 and is represented as rise over run, which is 2 over 1 in this instance. So if we were to look at it on this graph here to find our gradient, well, we know our run is 1, and we know that our run is our x-axis. So I'll start here and I'll go 1 across here. So that is our run. We know our rise is 2. So if I go up 2 units here, bang, that is our next point. And you'll see we have our rise 2 and our run as 1. So this number here represents our slope or our gradient using rise over run.